Okay, so hello everyone. I'm really glad to stay here and give a talk in front of you. So my name is Evgeny Sidorov and I'm security engineer at Yandex. Yeah, I'm actually principal security engineer at Yandex, and I've been working on different projects in information security field for about 10 years. And I have given lots of talks on international security conferences. This is my colleague Andrew, and we are kind of co-authors and friends, and we work in one security team. I'm also obsessed with traveling. This is my first time in Korea, and I really like the country and the culture and the food. So I'm really glad to be here. This is our agenda for today. So I'll be talking about two different open source projects. So like probably Yandex, like Nave, has a lot of different internal projects, but sometimes we open source something. And today I'll be talking about static analysis, a tool for analysis nginx configurations. I'll be giving some examples, and I'll give you some directions how to install it and where you can find the code. Hope you use nginx in your production processes. And I'll be talking a bit about password hashing. I'll present our library for Blake 2 and Argon 2 algorithms. So let's get started with gixy. Gixy is a SaaS tool for nginx configurations, and here is a short disclaimer because I'm not the author of the tool, and it was developed by my colleague, my colleague and friend Andrew Krasichkov, and he's, as I said, he is the author and the mastermind of the project, and all kudos should go to him. And in this case, I'm just a speaking head, and he kindly granted me his permission to give a talk. He actually he doesn't really like public speaking, so this is the first time a person presenting this tool, though it was released a year ago, and you can easily find the code on GitHub. Okay, so let's get started with some problems in nginx configurations. Here you can see the first problem, like a header redefinition, like just everything seems to be okay, but if you put add header statements here, and then you have location section, so this header extreme options won't be put in this response. So it's like an example of problems that can be found by gixy. So in this case, you're expecting that nginx will put extreme option header deny to all responses, but it will be dropped in location new headers. And sometimes our developers like misunderstand this, and it can lead some security problems. Let's take a look at other problem, host. We call it host spoofing, and about several weeks ago, there was a security advisory from Microsoft, ASP.NET, and they haven't disclosed the vulnerability itself, but they provided a way some ways how to mitigate this vulnerability. And one of the mitigations, just like put nginx in front of your application and control host header, and they suggested a configuration how to properly mitigate this issue, but my colleague Andrew, it's easy to see that this mitigation can easily be bypassed because the guys from Microsoft, they just forgot about the difference between HTTP host variable and just host variable. Just to be clear, I'm talking about this string. So they used HTTP host variable instead of just host variable, and it can lead to like easy bypass, and here you can see an example configuration that shows the difference between HTTP host and host. So the mitigation and sample configuration from Microsoft can easily be bypassed by, like, you can see this request on your left. Yeah. So there is I have one more example of such improper configuration. For example, if you take a look at bigo.me. As far as I remember, they provide kind of a CMS or something. I'm not really into their project, but they just in their documentation they also used HTTP host and this header host. So using this configuration, you can send any host header to your proxy path, to your backend sites, and so on. It's it doesn't lead to any security vulnerability immediately. It depends on your application, but as you could see from Microsoft ASP.NET, sometimes there can be an issue related to HTTP host header check. And let's go on. It's HTTP splitting. I mean, like, it's also usually called CRLF injection. Sometimes you can see in different literature, like some people divide this class of vulnerabilities in two subclasses, like request splitting and response splitting. It doesn't lead to kind of a vulnerability itself, but sometimes it's very useful if you want to put different bugs in a chain and then exploit it. For example, we had some nasty cases when you have an SSRF vulnerability and response splitting and HTTP splitting, and it can be turned into remote code execution and so on. So sometimes it's kind of a nasty bug. You can, like, exploit it in some session fixation issues. Sometimes you can turn such vulnerabilities into XSS and so on. Anyway, here you can see improper nginx configuration. So, some people use, like, an action group and put action in the header, and here you can see an example of exploitation. So you can put like any header to the response. Just to be clear, it's like you can see request and respond that the header injected into the response. So let's take a look at another real-world example. So you can just open right now Wordpress documentation. You know, Wordpress, it's a very popular kind of a CMS for blogging platform and so on. And you can see such strings. So it's they use URI variable, URI. I don't know, just because in Russian we usually call this variable URI, but like in English it will be URI, just different pronunciation. So they used URI variable, and you can easily inject, if people use this default configuration example from WordPress documentation, so the adversary can easily inject different headers in response. So here you can see an example of like triggering these bugs. So and here you can see an injected header. So and the next type of bugs, it's regex.pl. So we call it regex.pl because our developers usually make mistakes in regular expressions. For example, in nginx, you can use regular expressions for locations, but sometimes if you use coarse technology, I mean cross-origin resource sharing, you need to check origin header, and sometimes different mistakes in regular expressions can lead to nasty security bugs. Here you can see a real-world example from our internal configuration. So our developers made a mistake in regular expressions, and for example, you can go and register such domain like www.yandex.ru, I will come and bypass this origin check. And one more example, developers forgot about escaping dots in the regular expressions, so it should be like /dot, but they forgot about slashes, and in regular expressions dot means any symbol, so you can like buy the domain like www-yandex and everything will be bypassed. So sometimes it can lead to some nasty bugs. Yeah. Let's take a look at SSRF issues. I mean, it's server-side request forgery. Gixy, this tool can detect some easy cases. You can see it's just like a proxy pass, and sometimes developers want to proxy request. They want to proxy request to their backend service, but it leads to proxying any request inside our internal network, and this bypasses kind of firewalls and so on. So Gixy can easily detect such kind of bugs too. Okay, and it was about first example, and the second example is improper use of misunderstanding internal sections. So, for example, in nginx you can mark the location like internal location, and it can't be accessed from outside. It's just internal location, but some developers they forget about that. Rewritten request becomes internal, so you can just chain those two sections and get an SSRF vulnerability. It was just several examples, but the tool can detect a lot more, and you can provide, for example, your origin host name. It can, or for example, your origin, your host name, and so on. And it can resolve regular expressions, find suitable patterns, and so on. So at Yandex, internally we turned Gixy into a web service. So it's written pattern, and you can easily make a web version of it. So our developers they use it in both ways, like a web service and like a part of their continuous integration tool. So here you can see how to install Gixy. It's can be easily accessed from PyP repository, and you can check out the code and probably join and collaborate and send some pull requests and so on. So you can go to HTTPS GitHub Yandex Gixy and grab the code and take a look. Let's go to the second part of my talk. It's about large-scale password hashing. It's a project that I was working on for like half of a year, because at one point of time we decided to change our old password hashing scheme to a new one. I'll be presenting a short version of the slides, but at the end of the talk I'll provide you with a link to kind of an extended version, because I gave this like extended talk on DEFCON crypto Privacy Village, and I was talking about problems of large-scale password hashing in general, and how we did it at Yandex. So like yesterday I checked, I tried to set up a new account in Nave, and you're also using usernames and passwords. So surprisingly, you know that there are some security researchers that claim that passwords are dead, but surprisingly passwords are still alive. And it's a good thing. So I guess that passwords will probably always exist, and because it's easy way and users get used to it and they understand what is username and what is password, and they don't need to spend time to get used to other authentication tools and so on. And passwords, it's something that in two-factor authentication. So although you have although you probably have a two-factor authentication, you always need kind of a password for users to keep in their brain. And we can divide password hashing into you can do password hashing in 3 ways. So there are some non-interactive operations like password-based encryption, and there are some interactive operations like password-based authentication and so on in a web service. And these talk about the second part. It's about interactive and online operations. So here we can see we have an attacker and defender, and the biggest challenge here is that an attacker can use GPU, FPGA, ASICs, and so on to accelerate his brute force capabilities. But when you're developing a web service, you can use just multi-core service and so on. And the biggest challenge here is that your web service must hash a lot of user passwords, but sometimes, for example, if you dedicate a lot of time for hashing, you can suffer from computational denial of service. It will be exhausting resources and so on. As you can see, GPU, personally, I consider GPU is the most important case because there are a lot of people. I'm not sure about Korea, but in Russia there are a lot of people who mine cryptocurrency. They have a lot of GPUs available to do some computational job and so on. As for FPGA, you can rent in AWS some FPGA service, but it's pretty expensive, and GPUs are the most easy way to accelerate your computations. So let's take a look at modern algorithms. Several years ago, there was a password hashing competition, and cryptographers came up with several solutions for password hashing, and one of the solutions are called so-called memory hard functions. So it's kind of to mitigate different GPU capabilities, you use kind of a fixed amount of memory, for example, several megabytes for hashing one password, because you know that in GPU accessing memory, random accesses to memory are pretty expensive. So there was a password hashing competition, and it lasted about several years, and the guys who organized these competitions, they picked the winner. It's Argon 2, but the algorithm was developed by the guys from Luxembourg University. And there is one algorithm, YaScript. It got special recognition. It's not the winner, but I really like it. Anyway, at Yandex we opted for Argon 2D for hashing passwords of our users, and we were discussing how to pick the proper parameters, how to make it fast, and so on, how to build the overall password hashing scheme, because you know that the password hashing algorithm itself, it's not enough. And we came up with those steps. For example, at first we need to define your KPI for server responses, like, for example, how much time you can and how much memory you can dedicate to password hashing, but it's mainly memory is more important. Then you can optimize the implementation as much as possible. Then you can use benchmarks to figure out appropriate parameters, and then, as I said, the algorithm itself is not enough, so you need to apply some mitigations on the scheme level itself. For example, you can use local parameters, like crypto anchors, or for example, you can employ state-of-the-art partially oblivious pseudo-random functions approach. So those guys behind password hashing competition, they provide people with reference implementation, but the implementation uses March native parameters. Yeah, Argon 2 is written in C, is implemented in C, and they use March native parameters, but it's not convenient because you can easily run up against illegal instruction exception, because March native makes compiler optimize as much as possible the code as much as possible for current CPU architecture. And if you adjust the building process, and if you want to achieve some kind of compatibility between different types of CPUs, you'll lose about 15 or 20% of performance. So I had to make our own implementation, and it employs themed instructions as much as possible, and it runs CPU ID and picks the best, it picks implementation with the best performance runtime. And our library has Argon 2 and Blake 2B algorithms in it. So here you can see some benchmarks, so across different themed vector instructions. So you can see that, and everything is picked in runtime, so you can run it on on old service, and you can run it on state-of-the-art service, and you'll get the best performance in each case. And you don't need to recompile it, you don't need to rebuild it, everything will work fine across different types, across different models of CPUs. So our implementation called Argonische, it's like in Russian, it's the suffix she means something that is bigger, that scares small children and so on. So it's kind of funny. It's written in C++ 14 and released under BSD 3 clause license. And I have plans to implement everything, to add support for AVX 512 instructions. And as a bonus, because Argon 2 uses Blake 2B internally, we recommend, inside Yandex, we recommend to use it instead of SHA-1 and HMAX SHA-1, because you know SHA-1 is considered to be deprecated, and the collision was found by the guys from Google. So inside Yandex, we opted for Blake 2 instead of SHA-1 and HMAX SHA-1. Here you can find some links. So I was talking about like an extended version of the slides, and you can get from my Yandex, drive, extended version of the slides. You can get some more information about those mitigation techniques I was talking about, and there you can get like more information about the problem of large-scale password hashing itself. And if you like, you can check out the code. It's also on GitHub, and if you'd like, you can also like send pull requests, joining the process, the development process, and so on. And that's it. Now I'm ready to take your questions. So, and here is my contact. So, for example, if you don't have any questions right now, you can easily get in touch with me, and I'll answer your questions. Okay, thank you. So I invite here my colleague Andrew. Short break. That is great. Excellent. Okay, thank you for your attention.